Stop waiting for the green light and start building it yourself. Most people think you need a complex computer or coding to run a city traffic signal. But today, I'm going to show you how to master this entire system using nothing but basic electronic components. We're stripping away the microchips and going back to the pure, raw logic of hardware. If you've ever wanted to understand the secret rhythm of the streets, this video is for you. But wait until you see how these simple triangles in the middle actually decide which light turns on. It's not as obvious as you think. Let's get into it. Hey, everyone. Welcome back. In this video, we're using Proteus to simulate a real-world traffic signal. We're going to take a 9-volt battery and turn it into a timed sequence of red, yellow, and green. I'll walk you through every single part so you can build this yourself at home. Let's look at our parts list. We have a battery, some resistors, capacitors, 2 main chips, and our lights. It looks like a maze, but you'll see it's actually a very logical path. First up, we need a heartbeat for our project. Look at this first chip on the left. Think of this as the pulse generator. It sends out a steady electrical beat or signal. Without this, our lights wouldn't know when to switch. We've connected a few resistors and capacitors here to control the speed of that beat. Now here is a quick challenge for you. If I wanted this light to change every 10 seconds instead of every 2, which specific part here would I need to swap out? Drop your guess in the comments right now, and let's see who gets it right. Next, that signal travels to our second chip in the middle. This is the brain of the operation. Its job is simple. It counts the pulses coming from the heart. Every time it hears a beat, it moves to the next step. It's basically a 1 to 10 counter that resets itself automatically to keep the loop going forever. Imagine it like a clock that only goes up to 10 and then jumps back to 0. This keeps our traffic flow consistent, so the cars never crash in our simulation. Stay with me, because this next part is where 90% of people get confused and their circuit fails. Now, look at these small triangular symbols in the middle. These are like one-way streets for electricity. We use these to group the counts. For example, we want the red light to stay on for 4 beats, the yellow for 2, and the green for 4. These little components make sure the electricity goes to the right light at the right time without flowing backward. Without these, all your lights would probably blink at the same time and create total chaos on your virtual road. Finally, we have our output, the red, yellow, and green lights. These are standard LEDs. When the brain reaches a certain count, it sends power through those one-way streets we mentioned, and boom, your light turns on. It's satisfying to watch that sequence transition perfectly from green to yellow, and then finally to red. stick around for just another minute, because I'm going to show you a secret trick to make this circuit work with even higher voltages for a real-life outdoor project. Notice how the wiring looks? We've got a 9-volt battery providing the juice. The power goes into the timer. The timer talks to the counter. The counter picks which light to turn on. And the cycle repeats. If you want the lights to blink faster, you just change the value of those two big resistors near the first chip. It's that flexible. This is the exact logic used in basic electronics to automate almost anything without needing a single line of code. And there you have it, a perfect traffic light sequence running right on your screen. It's clean, it's simple, and it's the best way to start learning how electronics actually think. If you can master this circuit, you can build almost any automated timer in the world. If you found this helpful, hit that like button. Drop a comment if you have questions about the wiring. And don't forget to subscribe for more project builds.